Hey, welcome to Jed Foster Maths and welcome to part 3 of differentiation. In this video we're going to be going over the product rule and how you can apply it to different differentiation problems. So, what is the product rule? As the name suggests, this is used for when you have a derivative where you have the product of where you have two variables of x, right? So, for an example, if you had the product of x sine of x, this is where you would need to use the product rule. As you can see, you have two products of x, alright? So let's go over what is the product rule, how do you use it? So for the product rule, step 1, we need to set up a table, and we're going to call this u, v, u prime, and v prime. So step 1. We set that table up and we choose what we're going to set to u and we choose what we're going to set to v. This is a table and it works every time. It allows you to find the derivative where you have two different products. Alright. So let's set u equal to x. V is going to be equal to sine of x. And all we're doing, we're splitting up the product and we're putting it in this table. U equals x. V equals sine of x. You set one function equal to 1. So you set u equal to one function and then v is equal to the other one. And once you've done that, you need to differentiate both functions. So we know u is equal to x. V is equal to sine of x. So let's find the derivative of both these functions respectively. So we know x's derivative is just 1, and sine of x is going to become cosine of x. So once we've done that, the next part of the product rule says that we're going to take the product of v times u dash plus u times v dash. So we can say dy dx, our derivative, is going to be equal to v u dash plus, then we're going to have u v dash. So that's what the product rule is. We have a product where there are two functions of x, the same variable, so then we can set one function equal to u, one function equal to v, and then after that you differentiate both functions into u dash and v dash. I also recommend just sticking to writing it like this. It makes it very easy to read, and you want to have the same process because you're going to be doing this a lot, so you need to get used to how to write this out, and it's going to help you visualize what you're doing as well, especially with some more big and complicated derivative problems. Very good to be organized with these. Okay, so we can write this out. We know vu dash sine x times 1 can have 1 times sine of x, which is just sine of x, but I'm going to write down the whole thing. And then we're going to be adding u times v dash. So we're going to have x times cosine of x. And that's all it is. That's all there is to it. So that's what the product rule is. Then we can simplify it down a bit more. So we know our derivative is going to be equal to sine of x plus x cosine of x. So that's the product rule, a basic introduction to it. So let's move on to some little more complicated problems. And I want you to pause the video and give these a go yourself. So let's say, for an example, we had y equals, let's say we'll have ln of x times, let's say we had e to the 2x squared. Okay, so step 1, make the table. U, v. That's every time you get a product rule question, write u and v. And then over here we're going to write u dash, v dash, or u prime and v prime. That's just saying that's the derivative. Sorry, that's the derivative. So we set one function equal to, we can set u is going to be equal to the natural log of x, and then the other function that it's being multiplied by is e to the 2x squared. So we're going to have v equals e to the 2x squared. Okay, now step 2, what we need to do, we need to differentiate both these functions, alright? So we know ln x differentiates to 1 over x. E to the 2x squared is going to become 4x e to the 2x squared. And our product rule says derivative is equal to vu dash plus uv dash. Okay, therefore we have our derivative is going to be equal to, we're going to have e times 1 over x, that's going to be e to the 2x squared over, that's going to be over x, plus, we're going to have 4x times ln of x times e to the 2x squared. And if we wanted to, we can factor out an e, so we can say y dash is going to be equal to, can bring the e to the 2x out the front, e to the 2x squared. That's going to be multiplied by 1 over x plus 4x ln x. So that's another product rule problem. And as you can see, it's not much harder than the chain rule, like if not easier, in my opinion. And let's move on to another one. So let's say if you were given y equals, let's say, ln of, let's do cos of 2x times by, we'll have e sine of 3x. Now this is getting a little more complicated, and as you can see for this rule, we're going to have to use the chain rule in combination with the product rule. But let's set out our table, u, v, u dash, v dash. So we'll set u equal to ln of cosine of 2x, and v is going to be e to the sine 3x. So let's differentiate both of these functions. So we know ln of cos of 2x. Remember the chain rule, we diff in, then we diff out. So step 1, differentiate the inner function. So we're going to have u dash is going to be equal to, what's the derivative of the inner function? The derivative of cos of 2x, we're going to have to use the chain rule again. So diff in, differentiate the inner function. 2x differentiates to 2. And the derivative of cos of 2x is going to be negative sine of 2x. So that's the derivative of the inner function. I'm just going to write it, I need to write it a bit further out. Alright, sorry about that, guys. So that's the derivative of the inner function. Now we found the derivative of cos of 2x. We're going to find the derivative of the whole function. So we're going to be diffing out. So the derivative of ln of cos of 2x is we're going to be multiplying this by 1 over cos of 2x. Now let's differentiate e to the sine of 3x. Again, using the chain rule, diff in 3 cos of 3x times e sine of 3x. This is just your chain rule and the general rule for an exponential function. And if you don't know these, go back to my previous video. Make sure you're up to scratch with your basic derivative rules. And let's move on. So we know our derivative is going to be equal to v u dash plus u v dash. Okay, so this let's calculate this. We're going to have e to the sine 3x. That's going to be multiplied by -2 sine 2x over cosine of 2x. This can look a little messy at the moment, but what's important is we need to get numerically the correct answer and then simplify at the end where possible. Then we're going to be adding on u times v dash. So we know u ln cos of 2x. So we're going to have ln cosine of 2x multiplied by 3 cosine 3x e to the sine of 3x. And we can simplify this down a bit. So we can take y dash. We know that we have e to the sine of 3x, so that can be step 1. We'll take that out the front. E to the sine of 3x. Chuck some nice square brackets in there. We know that's going to be being multiplied by -2 sine of 2x over cosine of 2x. And we're going to be adding on 3. Let's do 3 cos 3x multiplied by ln of cos 2x. And then we brought the e out the front, so we can close that. And that's our general solution. We could probably simplify this down a bit further as well. We can simplify this down a bit further. We can do y dash equals e to the sine of 3x. And by the way, guys, if you don't know your trig identities and that kind of stuff, don't worry about it. It's still right. But we can simplify this down a bit further. That's going to become -2 of tan of 2x. Because sine x over cosine of x has the same inner function, so that will just become tan of 2x. Then we can add on plus 3 cos 3x multiplied by the natural log of cos 2x. That's probably as much as we need to simplify down. I'm sure you can go a bit further if you want to, but that's all we need to do for now. So this is your product rule, and let's end the video on one last question, and I want you to give this one a go yourself, alright? So let's say you have y is equal to e to the, let's say x sine of x. So I want you to give this one a go yourself, pause the video, then come back to it and I'll explain how to do it. So let's differentiate this. Y dash is going to be equal to, remember first up we need to set our table out. So let's do that first. U, V, U dash, V dash. And what I want you to recognize with this problem is that when differentiating an exponential, as in one of my previous videos on the power rule to differentiation and the introduction to differentiation, when when we're taking the derivative of a expo, it's going to be the derivative of the power. We're going to multiply it by the original function e, and then the power is going to remain the same. So we need to find the derivative of x times sine x. So again, u equals x, v equals sine of x. And let's set u dash. We know x is going to differentiate to 1. V, which is sine x, is going to differentiate to cos of x. So we know our product rule is v times u dash minus u times v dash. So we can say y dash equals, and remember, because we're multiplying the whole derivative by e, we're going to make some brackets. So we're going to have v times u dash, 1 times sine of x is just sine of x, plus, then we're going to have u times v dash. X times cosine of x is just x cosine x, multiplied by the original function, which is just e to the power of x sine of x. So that's all there is to it, and I think in this video we've covered most problems that you're going to encounter in terms of difficulty. And just remember, you're always applying the same rule to everything when it's a product rule, but sometimes you can get more complicated functions where you have the chain rule inside of the product rule. And as we're going to see in the next video on the quotient rule, sometimes you're going to need to use the quotient rule in combination with the product rule and even the chain rule. So it's all about recognizing the problem and using the right techniques and approaches to solve them. So now I've done this video, we've covered the basic introduction to differentiation, we've covered the power rule, we've covered some basic functions and their derivatives, and we've also covered the product rule, and we've covered the chain rule. So in the next video, it's going to be on the quotient rule. But always remember, Jesus loves you, I love you too. Have a great day. Bye.